Welcome to my video, Simple Pendulum, measuring the period with 3 different weights. So in this video, I want to validate an observation that's been known since the time of Galileo. Is a swinging pendulum appears to have the same amount of time regardless of how heavy the bob is. The bob is the weight at the end of the pendulum. So the question is, does the mass of the pendulum bob affect its period? And the hypothesis, using the scientific method, is the period of a pendulum is independent of the bob's weight, within certain restrictions of the material properties. So in the experiment, what I want to do here is I've got one pendulum of the same length, but I put 3 different weights on it. I put a 3.5 gram, a 6.8 gram, and a 13.7 gram weight, or bob, and the length is still the same, 32 centimeters. And so the purpose of this is to test whether changing the mass affects the pendulum period while keeping other variables constant, such as the length and amplitude. Okay, this is the experimental setup. It's just a basic lab stand. I've got 32 centimeters of fishing wire. That's a good, doesn't stretch and strong. And then at the end, I've got a lead weight, which is actually a fishing weight. They make nice weights. And so that's my setup. Now, my counter at the 0 swing, and this is with the 3.5 gram bob, and I do 10 complete swings, and it took 11.2 seconds. So the period now becomes 11.2 divided by 10, it's 1.2 seconds. So that's with the 3.5 gram bob. Now I want to do the next one, is with a 6.8 gram bob, and it took 9 complete swings, 10.26 seconds. So doing the math on this, 10.26 divided by 9 swings, the period is equal to 1.14 seconds. The third experiment is with a 13.7 gram bob. It took 10 complete swings. It took 11.3 seconds. So doing the math on this, we got 11.3 seconds divided by 10 swings. That gives us a period of 1.13 seconds. Let's calculate the theoretical period of the pendulum. So this is our formula. Period is equal to 2 pi times the square root of the length of the pendulum, which is in meters, divided by the acceleration due to gravity, which is 9.81 meters per second squared. The length is 32 centimeters, which is 0.32 meters. Doing the math here, we come up with a theoretical period of 1.13 seconds. And if you'll notice back from what we just did, that's very close to what we observed. So looking at the 3 different observations that we did on the period of the pendulum, so the mass of 3.5 gave us 1.12 seconds, 6.8 gave us 1.14, and then the 13.7 gram weight gave 1.13 second period. Okay, the average is 1.13. The standard deviation of those 3 observations is 0.01, very small. We have really good results here, which sometimes is a little scary when it gets that good. So the theoretical and the average agree with quite closely, actually. So what we can conclude from this is the theoretical period and the observed periods were in close agreement. So that's good. It's a simple experiment. They should have been fairly close. And another video I'll give you a link to. I did this again, and we got fairly close agreement. And then the second of the period of the pendulum was independent of the bob's weight with an experimental error. We could have got down to a much finer experimental process here and probably refined it a little better. And the experiment's hypothesis was that the period of the pendulum is independent of the weight was supported, though not conclusively proven. This was just one example of what can be done. We'd have to do an infinite number of experiments. So I hope you got something out of this, learn a little bit about how to measure the period of a pendulum, calculate the theoretical value, and draw a conclusion from what you've observed. If you did, give me a like, a thumbs up, subscribe to my channel, or thank you for watching.